This assessment points out that this step, unlike any step we've seen previously in an aldol reaction, is favored to the right. So usually this step in an aldol reaction between an enolate and an aldehyde would not be favored to the right, but here, when we're making a ring, it is favored to the right. Why might that be? Well, in the normal aldol reaction, when we're doing it intermolecularly, we're reacting two molecules, and they're combining to make just one. And so though those reactions might be favored by enthalpy, they're disfavored enough by entropy so as to make them not favorable. This one, because it's intramolecular, we basically have one molecule reacting to form one molecule. And so delta S is approximately 0. Now, it's actually going to be slightly negative because we're making a ring, but in terms of the translational entropy going from 1 to 1, we can think of entropy as being very, very small, even if it is a slightly negative number. Well, with that small contribution from entropy, we let enthalpy be the driving force. This enthalpically favored reaction then results in an overall KEQ of greater than 1. So why is this one favored? Because entropy matters less in the intramolecular reaction.